Hello everyone, welcome back. This is actually the third video in a small series that I'm making about this plane here, the ARWing. You may want to make sure that you look for the playlist and go back to the beginning if you want to go, I'm kind of describing this plane and showing you from the ground up what makes up the plane. We talked about an introduction, and then I also made a video that describes the airframe. And so this is the third video in the series, and it's basically going to describe all the electronics that go into making an autonomous flight vehicle like this one. What I'm going to do is I'm going to describe them and just kind of give you a general idea of what they're for. And also, I'm going to talk to you about them from, if you're going to make an unmanned vehicle, there's some pieces that you have to have, and there are some pieces that are, if you will, optional. So I'll first go in that order from what you must have to what you don't. And because we're talking about making an autonomous vehicle, we are going to start with a flight controller. This flight controller here is the Maytech Systems F405. And what this is a flight controller that can run a software called Ardupilot. It comes from the family of Ardupilot software. I have a few connections here. You basically get everything that you see here, the blue board, and you need to do some soldering at a battery terminal. I also added a capacitor to smooth out the voltage. These little connectors here are for a little screen that you can connect to it, so you get some flight information as you are at the flying field. This here is an ESC. And the reason you see that like that is because I have very tight space inside that airframe, and I'll show you how it fits. But basically the space is so tight that I took the heat shrink off of this ESC and took some of the wires that normally would be soldered here and come out that way. So I desoldered them and made them come out the other way so that it's as short as possible and it will fit inside the fuselage. So that's the ESC. The ESC has a signal wire cable, both a ground and a signal, and they go right here in that position. This flight controller can control up to 2 different motors. So on the right is motor 1, on the left is motor 2. And by that, it really means the connection to the ESC. And these are the 3 plugs that go to the motor. Now, I'm assuming that you have a level of familiarity that this is probably not going to be an entry-level plane for someone to build. If you would like more details, just let me know in the comments and I can, go into a little bit more into the ESCs or a little bit more into the flight controller itself. I just want to keep this video relatively straight and to the point just with regard to the electronics. So this flight controller will go inside the plane here towards the back of the fuselage. And you will see that there isn't a lot of room, but because I made it as short as possible, I'm able to place the flight controller almost starting to go into that back part of the fuselage and just save as much room as I can for the rest of the components and of course the battery. So that will be where the flight controller goes. The battery that I'm using for this plane is a LiPo battery, and this is actually one of my older batteries. I'm using newer batteries than this for when I actually fly it. This is more what I used to test on the bench. But these are the same size batteries. These are LiPo batteries, 3-cell, 2.2 amps or 2200 milliamps is that's equivalent. And it sits here at the front. The weight towards the front is necessary to balance the plane, so that's where the battery goes. And there's your flight controller. Another thing that you're going to need to be able to fly this as an autonomous vehicle is a GPS unit. You can't see it very well here, obviously, because I put some tape over it. But that's right about the size of the GPS unit. So there's my thumb for comparison. It's not very big at all. It's kind of small, but I managed to put it far enough away from magnets. See, the magnets are over here towards the front of the nose of the plane and in here. And the motor's also got some magnets in it. But by putting it in that wing over to the side, I managed to get enough clearance to where I can use the compass or magnetometer that is included with this GPS unit and I am getting a decent enough signal, and it, you know, when it's ready at the flying field, it will get up to 18 satellites. You need minimum 6 to be able to do autonomous flights. So sometimes it's hard to test it when you're indoors, but once you're outdoors, you're gonna get plenty of satellites and be able to fly. I'll remove this for weight. Now, the next component that you have to be able to fly your plane is a radio receiver. And the one that I am using here, of course, I put shrink wrap over it now, but I'll put a link so you can see good pictures and details about the radio receiver. But this is the FR Sky R9MM radio receiver. And it's a 900 megahertz radio. A lot of the, I would just say, more common radio systems use 2.4 gigahertz. The 2.4 gigahertz band is shared with Wi-Fi. Not that at the flying field there's a lot of interference, but the lower range radio systems also have a little bit longer range. This particular receiver requires that I have a 900 megahertz radio module. So that's what I have here on the back of my radio, which is a Taranis X Lite. It does need some additional extra power, and I just use this tiny battery. I'm thinking of getting a full-size radio transmitter for Ardupilot, especially because I use all the flight modes, and I would like one that has a bunch of buttons across the top, so I'm looking to get that upgrade. But I managed to find the adapter, and you make a connection between the adapter and the radio, and then you can use this module, which is basically the long-range radio system module at 900 megahertz. So this will go somewhere in here, and it will come out top and bottom of the plane. But the idea is to mount it vertically with the indicator in the same direction on both the transmitter and the receiver. So I have another antenna. That's just a straight dipole antenna on the radio, but I have another antenna that does have an indicator. So when you're flying it, you want to have them vertical, and that indicator either pointing up or pointing down, both on the radio and the receiver, on the transmitter and receiver. So those are the electronics that you have to have in order to be able to fly. And some people even get GPS units without the compass, and for planes, it's fine. It does give you a little bit of added advantage because it will allow the plane to crab and track better. But if you don't have a compass, you can still fly because planes fly mostly in one direction. The GPS unit will provide more than one reading and then be able to figure out which way you're going and calculate a heading. The other thing that I feel is super important to have is a buzzer. Let me move this a little bit out of the way so I can show you this a little bit better. So this is a V-Fly Finder tube, and it has a little battery. And that's important because sometimes, especially in a crash, your battery may eject, may break. One time I had a little fire in there because a couple of wires got crossed. And for whatever reason, you may not have power to your buzzer once you have a crash situation. And if you've been in this hobby before, like I'm expecting most of the people watching this video are, you know what I'm talking about. It's super hard to find a plane once it goes down in the woods. So this is a buzzer. You can activate it with the radio, but if for whatever reason it loses power, it will start beeping, and it will beep for at least a day or two with that little battery. So I'm going to give you a link to this in the description where you can go find the buzzer, but I would just not fly my plane without this. And to top it all off, I added another buzzer. I think I got this a few months back, and now they make one that's even, or their newer versions of it are even louder than this. But I ended up putting another buzzer just so that I make sure that when my plane goes down, I have a good way to find it, and I want to find it quickly, and I want to be able to find it as I'm walking through the woods. I want to hear it 50 feet, 100 feet away, and just be able to quickly go to it. Because we're flying with a flight controller, it has an OSD, and it has the GPS system. I'm always looking at the coordinates in the goggles. So when I go look for my plane, and believe me, once or twice that it happens is enough to justify all of this trouble. The goggles will have the GPS coordinates. I put that in my Google Maps on the phone. I get close enough, and then the buzzers lead me straight to it. Okay. Another component or piece of electronics that I think you want to have is some sort of digital camera for HD recording. This plane will support a GoPro and other cameras. Those, I always find it a little bit hard to justify the price for those cameras. Maybe if we get enough viewership and people want a better quality camera, I may get a GoPro at some point. But for now, I'm using this, which is the Runcam 2. It's a very decent, actually a good friend of mine gifted it to me, and he said, just get it in the air, get it flying. So here's what I'm doing. And it has a very good place. I talked when I went over the airframe on how that is mounted, and it sits right in there. It's super nice, super tight. It came with this little tether strap. And what I do to make sure that I have some kind of level of redundancy is I put a little tether. I'm doing this through the camera, so it's hard for me to see, but you get the idea. I just loop it through there. It also goes in here, and now it's double tight. Again, another piece, another component that may tend to get ejected in a crash. So that little strap will make sure you don't lose it as easily. I know because I lost Movio's camera probably about 1.5 years ago because it was not tethered to the airframe. So you want to tether it, and this produces very good quality video and makes it easy to have something you can show and watch, and people will actually, if you have any friends or family or anybody else that you're sharing video with, you do get video from the FPV camera, but this gives you a nice high definition quality video that you can share. And this is what one thing you want to have if you're going to be recording videos and sharing them. And since you're going through all the trouble, well, probably most people will want to do that. So speaking of cameras, another optional piece of equipment that I really like is the FPV equipment. And you begin with a camera, and this model in particular has a setup for the HD camera. As I told you before, there's the lid that will cover the HD camera, but you get this little shoulder camera. And this is an FPV camera. I happen to have the Runcam Eagle. This is a Lumineer edition, but they make a few editions of this camera. And what it is a full-size camera. They make smaller cameras than this, but this plane is molded for a full-size, they call this a full-size FPV camera. And it takes it right there, route it through the wing into the fuselage, and that's how you get your video. The reason, even though something like this has a harness that will give you video output, typically high-definition cameras have a little bit more latency. And if you're going to be flying in a manual mode, that may be too much latency. So that's why I took the video cable, which is this yellow one, and I just wrapped it back onto itself, and I put some electrical tape. So I only power it so it'll charge and not run out of battery. And actually, I don't even have to charge it anymore because it's just kept charged from when I fly. And this is what I use to see. Now, this video cable, this will go all the way to the flight controller. The flight controller then takes that video signal and puts an OSD layer on top of it. And it goes to my video transmitter. So I talked briefly about this video transmitter. This form factor is perfect, even though this is not the longest range transmitter. It's meant for racing. You can unlock it and get a little bit more power out of it. Again, I'm not advising that you do anything that you shouldn't do, but if you have a ham license, then you're able to unlock it and use the full power, which is up to 400 milliwatts. That's the TBS Unify Pro high voltage, which means that it can take voltage from the battery. I do happen to get it and connect it into the flight controller. This flight controller has all kinds of power management, which is what makes it so great for wings. So it actually has connections in here for plugging in your camera, which are, basically the camera, the ground, the 9 volts, which are going to be your pins here. And then for the VTX, it will also supply 9 volts to it. And so those are basically the places where I plug in the camera and the VTX. I'm not going to go into too much detail about the flight controller. I can make a video just about the flight controller if there's interest in me doing it. but there's plenty of videos about this flight controller that describe it in a whole lot of detail. So I'm just telling you how I use it and the reason why I don't use this to fly with. I use the camera, the FPV camera over here, and I use the VTX. The VTX, once it gets the video signal from the flight controller, it will then pipe it through this antenna, and this is just an MMCX connector to an SMA connector. I put it through this, and as I talked about before, just reinforce it with zip ties and plastic so that the foam doesn't get crushed. And that's a TVS Triumph antenna. I'm getting very good signal. I mean, I mentioned that this is meant to be a racing video transmitter, but within visual line of sight, where you can see it, you can certainly get the video signal, and you just get a very decent quality signal on your goggles. So that's how I like to fly it, but you don't have to have it. You can fly it just line of sight, and especially if you're going to be putting Ardupilot on it, it's going to help you with flight stabilization and all those neat modes that are the reason why people go to Ardupilot and Arduplane, and really help you fly very well, very easily. Now, I talked about the motor a little bit, but I want to mention that this is a motor that I put in here just to replace the stock motor. I happen to have one of these that is actually a racing motor from the FPV WRA. That's the FPV Wing Racing Association, and it's a 2310 2200 kV motor. I run this with these props, which are the Gemfan 6042 propellers. They are a very good fit for it. I may eventually go for a lower kV motor with a larger prop, but that prop and motor combination is well matched to each other. Now the ESC, I showed you that when I put the flight controller in there, that this ESC basically is one that I took apart, but just so that you know what it is, it's a 30 amp ESC that I had from an old quadcopter build, and it's an opto ESC. Opto means that it doesn't have a BEC, any kind of other power management, but I don't need it because this has plenty of power management. Okay, another optional component that you don't have to have, but it's really nice to have, especially once you get into Ardupilot and maybe eventually you want to do some autonomous flights that involve landing, autonomous landing. The Pitot Tube is a really nice sensor to have. And what it does is it calculates the airspeed and not just using the ground speed calculator from the GPS. Because the airspeed, of course, can be very different from the ground speed, and you want that for calculating a glide path in for landing, and you want it to prevent stalls. So overall, it's useful to have it. It's a little bit tricky when we talk about flying it. I'll mention that if you're going to use a speed sensor, it needs to be well calibrated, working properly, because Ardupilot actually will use the data, and if it's got bad data, you're probably going to crash your plane. Ask me how I know. So that's the other thing. The only other additional piece that I've got, and I mentioned before, but I'll mention again because it's the electronics video, are my little LEDs on the wingtips. I have a green and a red one on the wings, and I have a red here on the back of the plane, just to kind of give it that effect, you know, that it's burning through that jet fuel and dashing through the sky. Anyway, kind of like that. The other thing that I'm working on, and this is where I'm at in my own development of this plane, is a companion computer with a cellular modem. Now what this will do is it will give you a backup link for the radio control, and it will give you in-flight telemetry. Because I am using the 900 megahertz radio, you don't really want to use a 900 megahertz telemetry radio, which is typically what Ardupilot pilots use. So I would either have to change my frequency for one of the two, or I can do this. And what this is a Raspberry Pi Zero. It's running software called UAV Cast from a company called UAV Matrix. And it controls the cellular modem connection. This is a 4K, I'm sorry, a 4G modem that basically gives a link back to my cell phone and to my ground control station. And it also has its own little camera, so that basically, if for whatever reason you didn't have a video link and you didn't have a radio link, you still have another means, a redundant means of communicating with your vehicle and to see an image that, even though this is not going to be the frame rate of an FPV camera and an analog transmitter, it's going to be a digital image that at least shows you that your plane's still flying. So I think that's it. That's really all the electronics. As you can see, it's quite a bit. But like I said, not everything has to be put in place all at once. At a minimum, your flight controller, your GPS unit, your radio receiver, and I would throw this into as a minimum, your buzzer. And with that, you can very well get started, and then maybe you can add some of the other sensors later as you get more comfortable with it. You can add the FPV, you can add the speed sensors. Oh, I forgot to mention one. Also for landing, I have here a LiDAR sensor. So this is the TF1 from, I believe, Beneke. And it's a laser rangefinder. And basically this one points a laser to the ground and gives the vehicle a very, or a much more accurate distance to the ground. And it uses that when landing. So the plane will be coming down and it will do a flare and land. So that's what that is used for. It does have a barometer, but the barometer, which is in here, is not quite as accurate for doing that type of maneuver when landing. So the laser rangefinder is well supported with Ardupilot, and you can get different models. There's other models that give you much greater height than this. I think this one goes up to 12 meters, but that's enough to come in, control the landing, and flare, and have a nice soft landing. I'm gonna stop here because the video already got quite long. I didn't cover the specifics of the radio, but this is the X-Lite from FR Sky. It's a Taranis line, and it's running OpenTX. So that's all I'll mention about that, because we could do a whole video about each one of those pieces. But hopefully, you know, you like it. You get an idea of what it takes to put together a UAV, really capable aircraft, and all of these things need to fit in there, and you need to still be able to close it and keep it aerodynamic. So we'll do that. I think the next video I'll show a little bit about that, and maybe we'll do, I don't know if we'll be able to cover everything on one video, because I don't want to make these too long. But anyway, that's the overview of the electronics. I hope you liked the video. If you have any questions, please put them down in the comments. Let me know if you like the videos. Do you like the format? Are these long enough? Are these too long? Do you want me to focus just on one or two things so that you can just go to that video? I'm just starting with this, doing YouTube videos, so let me know. I can kind of tailor things a little bit more so that they're more enjoyable. Thanks a lot. Please share, subscribe, and all that good stuff. Bye-bye.